So in this video, we're going to talk about how to identify extraneous solutions. So when you solve square root equations, sometimes you get an answer that isn't actually a solution to the equation. This is what's called an extraneous solution. You can test for these solutions by plugging your answers back into the original equation and checking which solutions make the equation true. So let's try this problem. Let's try solving for x. So first you need to isolate the square root. Notice that the square root is not by itself because there's an extra plus 6 right there. So we're going to undo that 6 by subtracting 6 from both sides. So when we subtract 6 from both sides, we end up with the square root of x plus 3 equals 2 minus 6, which is negative 4. Now we can undo the square root by squaring both sides of the equation. So when we square both sides of the equation, we get x plus 3 equals negative 4 squared, which is 16. Now to solve for x, we're going to subtract 3 from both sides, which gives us x equals 13. So now we need to plug back into the original equation to see if this makes the equation true. So when we do that, we get the square root of 13 plus 3 plus 6 equals 2. The square root of 13 plus 3 is the square root of 16, so we have square root of 16 plus 6 equals 2. Square root of 16 is 4, so we have 4 plus 6 equals 2, which tells us that 10 equals 2, which is not true. So that means we have no solution to this equation because we only found one solution and that solution did not make the equation true. So now you can go ahead and pause the video and try this example on your own. So to isolate the square root, we need to subtract 7 from both sides. Then we square the equation and find that x equals 12. When you plug back x equals 12 into your equation, you get the square root of 9 plus 7 equals 4, which tells us that 10 equals 4, which is not true. So once again, we have no solution. So now let's try this problem. We have the square root of x plus 4 equals x minus 2. The square root is already isolated, so now we need to solve by squaring both sides of our equation. So when we square both sides of our equation, we end up getting x plus 4 equals x minus 2 squared. Remember, x minus 2 squared is where we have to use FOIL, right? So x minus 2 squared equals x minus 2 times x minus 2. So we're going to multiply the first terms, which are x and x, which gives us x squared. We multiply the outside terms, which are x and negative 2, so that's negative 2x. Multiply the inside terms, which are negative 2 and x, so that's negative 2x once again. And then we multiply the last terms, which are negative 2 and negative 2. So that gives us 4. Now we combine all these terms together and we get x squared minus 4x plus 4. Because remember, these two middle terms will combine to give us negative 4x. So now I can plug in x squared minus 4x plus 4 into my equation for x minus 2 squared. So this is a quadratic. Remember, in order to solve a quadratic, I need to set my equation equal to 0. So I'm going to start off by subtracting x from both sides. So when I do that, I get 4 equals x squared minus 5x plus 4. Now to solve for x, I'm going to subtract 4 from both sides. So when I do that, I get 0 equals x squared minus 5x. Now I need to solve 0 equals x squared minus 5x. So I can solve this quadratic, remember, by factoring. So in this case, when I factor, I'm going to factor by GCF because both of my terms have an x in them. So I'm going to factor out an x. So that means I'm going to divide out an x from every term. And when I do that, that gives me x times x minus 5 equals 0. So by the zero product property, since I have two factors that equal 0, I'm going to say x equals 0 or x minus 5 equals 0. X minus 5 equals 0 tells me that x equals 5. So now I need to check both of these solutions in my original problem. If I check x equals 0, I get the square root of 0 plus 4 equals 0 minus 2. So that tells me the square root of 4 equals negative 2. So that says that 2 equals negative 2, which is false. So 0 is an extraneous solution. Now if I plug in 5, I get 5 plus 4 equals 5 minus 2. So the square root of 5 plus 4 is 9, so that I have 5 minus 2, which is 3. Square root of 9 equals 3 is true because 3 equals 3 is correct. So that means that x equals 5 is the only solution that I have. x equals 0 is one of my extraneous solutions. So now you can go ahead and pause the video and try this example on your own. So in this problem, we're going to square both sides of our equation, which once again gives us a quadratic. So we have 5 equals x squared minus 3x plus 1, and we're going to set it equal to 0 by subtracting 5 from both sides. So we can factor this. Remember, we need two factors of -4 that add up to -3. Since my product is a negative number, I know that I need a positive number and a negative number as my factors. Since the number I needed to add up to, 3, is negative, I'm going to make my bigger factor negative. That's how I get the combination 1 and -4. So when I factor this, I have x minus 4 times x plus 1. So I set each factor equal to 0, which gives me x equals 4 and x equals -1. When I check my solutions, I find that x equals 4 makes my equation true, but then when I plug in x equals -1, that does not make my equation true. So x equals 4 is the only solution to this equation. So in summary, remember that once you solve a radical equation, remember to always plug your answers back into the original equation to check for any extraneous solutions. Remember that a number is a solution only if it makes the equation true.